In this class, we're going to go over questions on function. Okay, let's say you are given this. Let's say you are given that f of x is equals to 2x squared plus 1. And you are asked to find f of 0, f of negative 3, then we have f of r, then the fourth f of r plus s. Okay, we are given this. We are given that fx is equals to 2x squared plus 1. We are asked to find f of 0, f of negative 3, f of r, and f of r plus s. Now, let's start with the first question, which is f of 0. Now, all you have to do is that you just have to replace 0 as the value of x in this function. You understand? You know that the function that we are given is, please pay attention, the function is f of x is equals to 2x squared plus 1. Now, to get f of 0, all you have to do is that just replace the value of x as 0 in the function that you are given. Okay, now we are given that fx is this, so f of 0 will be 2 plus 1. You understand? So here I'm going to have 1 because 2 times 0 will be 0. Okay, I mean this should be square rather, so 2 times 0 will be 0, that will be 1. Okay, so we are done with the first one. For the second, we have f of negative 3. To get the value of f of negative 3, all you have to do is that just substitute the value of x as negative 3, okay? So for this, you are going to have f of negative 3 will be equivalent to 2 multiplied by negative 3 to the power of 2 plus 1, okay? So negative 3 to the power of 2 is 9, okay? 9 times 2 will give us 18, okay? So that will be 18 plus 1, which is what? 19, okay? So f of negative 3 is 19. Now for the third one, go ahead and try it. Try the third question, which is f of r. All you have to do is that just replace the value of x as r. You understand? So in that case, we're going to have f of r will be equivalent to, now when r becomes x, I'm going to have 2 multiplied by r to the power of 2 plus 1, which is what? 2r squared plus 1. You understand? So that is the third question. And for the fourth, we have f of r plus s. We are still going to go the same way. All you have to do is that just replace x in this function as r plus s. In that case, we are going to have f of r plus s will be equivalent to 2 multiplied by r plus s to the power of 2 plus 1, okay? So if you expand, you're going to have 2, we have r squared plus 2rs plus s squared plus 1. You understand? If you take the expansion of this, you're going to have this, okay? The meaning of r plus s squared means r plus s multiplied by r plus s. And if you are part of our class on the expansion, you'll be able to solve the question, okay? So now, having expanded this, you just have to you can use this tool to multiply all the value that's inside the bracket. So I'm going to have 2r squared plus 4rs plus 2x squared plus 1, okay? So the function f of r plus s is equivalent to this, okay? So you can see that that one is a bit simple. Okay, now let's look at a more complex one. Okay, let's consider the question that we have on the board. fx is equals to 3x squared plus 2x minus 1. We are asked to find fx plus h, f of x plus h minus fx all over h. Okay, how do we go about this question? Well, let's first deal with the numerator, okay? The numerator here is f of x plus h minus fx, okay? So for this, we are going to have, please pay attention, f of x plus h minus f of x will be equivalent to, please pay attention, see, you first substitute the value of x as x plus h in the function that we are given, okay? Notice, when we start the question, we are given that fx is equivalent to this, right? So, to get the value of f of x plus h, you have to substitute the value of x, you replace x in this function as x plus h. Do you understand? So, for this, I'm going to have, when x is x plus h here, I'm going to have 3 multiplied by x plus h squared, right? Because the value of x is raised to the power of 2 here. Hence, if x is substituted as x plus h, I'm going to have x plus h squared. You understand? So for this, I'm going to have plus 2 multiplied by x plus h minus 1. Okay? Now, having done that, we have the second, you see, I'm done with this. Now we have this minus f of x. Don't forget that f of x has been given as 3x squared plus 2x minus 1. So I'm going to have minus f of x. F of x is what? 3x squared plus 2x minus 1. So I'm going to have minus 3x squared plus 2x minus 1. Okay? Now, don't forget that we are still dealing with the numerator, okay? So for this, I'm going to have 3 multiplied by, now, if you expand this bracket, you're going to have x squared plus 2xh plus h squared, you understand? Plus 2 multiplied by x plus h minus 1, okay? Now for this, we're going to have minus 3x squared minus 2x plus 1, okay? So let us proceed. Here, I'm going to have 3 times x squared. I'm going to have 3x squared plus 6xh plus 3h squared. Now, plus 2x plus 2h minus 1, okay? Now, I'm going to have here minus 3x squared minus 2x plus 1. Now, having simplified, the next step is that we have to collect like terms, okay? Like terms simply means adding the terms that are similar to each other. Now, you can see that we have positive 3x squared here. We have negative 3x squared here. Here, I'm going to, this can cancel this. You understand? Okay? We have negative 2x. We have positive 2x. So, this can eliminate this as well. And we have positive 1, and negative 1. So, this can eliminate this. So, we are left with 6xh. You understand? I have 6xh plus 3h squared plus 2h. That is what we are left with. This, and this. Okay? Now, don't forget that this is the numerator of what we are asked to find. This is the numerator of the function that we are asked to find. So, now, having gotten the numerator as this, don't forget that the numerator is what? H. So, just put h. F of x plus h minus f of x all over h will be equivalent to, now I'm going to have 6xh plus 3h squared plus 2h all over h. You understand? Because when we take the function, when we deal with the numerator, we got this. So I replaced that this. Now the denominator is h, so I substitute it as h. Do you understand? Okay. Now having done that, the next step is that just divide all through by h. That is, you're going to have 6xh all over h plus 3h squared all over h plus 2h all over h. So 6xh all over h, that will be what? 6x. 3h squared all over h, that will be what? Plus 3h. Now 2h all over h, that will be what? Plus 2. So the solution to that question is 6x plus 3h plus 2. Do you understand? Okay, so that is a typical example of question on function. So let's look at one more example. Okay, let's consider the question that we have on the board. we have if f of x is equals to 2x plus 1 and g of x is equals to x squared plus x minus 1. Find g of fx, b f of gx, c g of f of 1, d g f of g minus 2. Now you see the way this function is written, I can rewrite this function as this: g of fx, you understand, and this as f of gx, and this as g of f1, then this as f of g minus 2, f of g minus 2. You understand? Okay. Okay, so you can see the meaning. Okay, let's start with the first question. Please pay attention. The meaning of g of fx is that is, you know that g fx is what? 2x minus 1 2x plus 1. Fx is 2x plus 1 and gx is x squared plus x minus 1. Now g of fx means that anywhere I see x in gx, g of x, please pay attention. Anywhere I see x in g of x, that is, I'm going to substitute the value of x as f of x. Let's go. For this now, I'm going to have g of fx. Don't forget that g of x is what? X squared plus x minus 1. Now, g of fx will be now g of f of x. That will be I'm going to replace the value of x as 2x plus 1 in anywhere I see x in g of x. Do you understand? So that is the meaning of that statement. For this, we are going to have, when I have x squared, I'm going to have 2x plus 1 squared, 2x plus 1 squared plus 2x plus 1 minus 1. So for this, I'm going to have, this is for question here. So if you expand this, you're going to have 4x squared plus 4x plus 1. Okay, now for this, I'm going to have plus 2x plus 1 minus 1. So 4x squared, 4x plus 2x, that is what? Plus 6x. This will eliminate this, so I'm going to have plus 1. Okay, so the final answer to that question is 4x squared plus 6x plus 1. Okay, that is the solution to the first question. Now for the second question, we have f of gx. That's for question B, f of gx. Now for this second question, f of gx, that means that, don't forget that fx is what? 2x plus 1. So f of x is equals to 2x plus 1. Now that means that since we have f of gx, that means that anywhere I see the value of x, anywhere I see x in f of x, I'm going to replace it as gx. You understand? And don't forget that gx is what? X squared plus x minus 1. So for this, I'm going to have f of gx, f of g of x will be equals to 2 multiplied by, now gx is what? X squared plus 1. So I'm going to have x squared plus x, x squared plus x minus 1. Okay, plus 1. Okay, please just pay attention, it's simple. Okay, when I start the first example, I gave you something like f of 0, f of 1, you know. Now we have f of gx, f of g of x. Now that means that I'm going to replace, anywhere I see x in f of x, I'm going to replace that with gx. And don't forget that gx has been given as x squared plus x minus 1. Okay, so for this, I'm going to have, and that's how I arrive at this place. When I see x in fx, I substitute x squared plus x minus 1, because x squared plus x minus 1 is equivalent to what? Gx. So I'm going to have here 2x squared plus 2x minus 2 plus 1. Okay, that will be 2x squared plus 2x minus 1. Okay, that is the final answer. Do you understand? Okay, now we are done with question B. Let us proceed to the third question, which is question C. So I want you to pay attention. Okay, it's simple. And understanding this basic function will help you to will ease you of the problem of the difficulties of the complex one. You understand? So kindly pay attention. Now for the third question, we have g of f of 1. That is g of f of 1. That means that let us take it step by step. Question C, g of f of 1. That means that we have to first find f of 1 before we can find g of f of 1. Listen. G of f of 1. We have to first find f of 1. And don't forget that f of x is equal to what? 2x plus 1. So f of 1 will be equal to what? 2 multiplied by 1 plus 1, which is equivalent to what? 2 times 1 is 2, 2 plus 1 is 3. So I'm going to have 3. Do you understand? Now, having gotten g of f of 1, having gotten f of 1 as 3, we can get g of f of 1. What are we going to do? All you have to do is that just substitute f of 1 as the value of x in the g of x that we are given. Okay? Now, don't forget that g of x is what? X squared plus x minus 1. Now, we are taught to determine g of f of 1. Now, we need to find the value of f of 1. That is, when x is 1 in fx, what will that value give us? It gave us 3, right? So, having done that, all you have to do is that just substitute the value of 3 as the value of x in g of x. Do you understand? So, for this, we are going to have, don't forget that g of x is what? X squared plus x minus 1. So, g of f of 1 will be, instead of x squared, I'm going to have 3 squared plus 3 minus 1. That will be 3 squared is 9. 9 plus 3 is 12. 12 minus 1 is 11. So I'm going to have 11. Do you understand? Okay. Now, for the fourth question, you are asked to determine f of g of negative 2. F of g of negative 2. For the fourth one, we have f of g of negative 2. Now, we are still going to approach it as we did for the third question. Before you can determine f of g of negative 2, you have to first find g of negative 2. Now, we have been given that g of x is what? X squared. G of x is what? X squared plus x minus 1. So g of negative 2 will be what? Negative 2 to the power of 2 plus negative 2 minus 1. You understand? Okay, having done that, you can simplify to get your answer. Negative 2 squared will give us what? 4. Abi? Yes. I'm going to have 4 plus 1 multiplied by negative 2. I'm going to have negative 2 minus 1. So, g of negative 2 will be 4 minus 2. That is 2. 2 minus 1 is 1. Okay? That is also 1. Now, having gotten 1 as g of negative 2, we can now find f of g of negative 2. All you have to do is that, since we know that f of x is what? 2x plus 1, that means that f of g of negative 2 will be f of 1. You understand? Because g of negative 2, please pay attention. G of negative 2 is 1, right? So I'm going to have f of 1. Because when I evaluate this, I got 1. So I'm looking for f of 1 now. Do you understand what I'm doing at all? Okay? I'm asked to find f of g of negative 2, but I cannot get this function without without first getting g of negative 2. Having gotten g of negative 2 as 1, g of negative 2, I got it as 1, so I replace g of negative 2 as 1 in this function. So what I'm looking for now is f of 1. And don't forget that f of 1 is also the same thing as f of g of negative 2. Do you understand? Okay, so let us proceed. F of 1 will now be equals to, what I'm going to do now is that I'm going to substitute the value of x as 1. You understand? So I'm going to have 2 multiplied by 1 plus 1. That was 2 times 1 is 2, 2 plus 1 is 3. So the final answer to this is 3. Do you understand? Okay, so that is the solution to that question. I'm very sure. Please kindly take note of all these basic concepts, okay, so that when we go to the complex one, you'll be able to solve it. Now, okay, let's consider the following questions on function. If f of x is equals to x squared plus 6x plus 1 and g of x is equals to 2x minus 1, find f of x plus g of x. B. G of x minus f of x. C. F of x multiplied by g of x. D. F of gx. C. G of fx. And f of inverse of gx. Now, please pay attention. We are given that if f of x is equals to f of x is equals to x squared plus 6x plus 1 and g of x is equals to 2x minus 1, we have to calculate f of gx plus f of x plus g of x. Then 2, f of x minus g of x. Then 3, we have f of x, g of x. Then 4, we are asked to determine, please pay attention, f of g of x. Then 5, we are asked to find g of f of x. You can see that the question is a bit long. Then for question 6, which is the last question there, we are asked to determine f of g inverse of x. Okay, we are going to take it step by step. Okay, so I want to pay attention. Now let's start with the first question. We are asked to determine f of x plus g of x. Now, how do we find f of x plus g of x? All you have to do is that, since you know that f of x is what? X squared plus 6x plus 1, and g of x is 2x minus 1. You just have to take their sum, okay? So that will be x squared plus 6x plus 1, that is for fx, plus 2x minus 1. Okay, for this like time, so we're going to have x squared plus 8x x squared plus, okay, yes, then that's the answer. Okay, now let's proceed to question 2. We are asked to determine f of x minus g of x. That is question 2. F of x minus g of x. Now for that one, we are going to have x squared plus 6x plus 1 minus, okay, 2x minus 1. Okay, please kindly be careful. The negative sign is affecting both 2x and negative 1. You understand? So that will become x squared plus 6x plus 1 minus 2x plus 1. Okay, so for this I'm going to have x squared, okay, plus 6x minus 2x, that is what, plus 4x. Okay, plus 1, that is plus 2. That is the final answer for question 2. Now for question 3, we have to determine f of gx multiplied, f of x and g of x. That is that the sign between f of x and g of x now is a product sign. Okay, so we're going to have f of x, then g of x. That will be f of x times g of x. F of x is what? X squared plus 6x plus 1 multiplied by, what is g of x? G of x is what? 2x minus 1. Okay, so for this we are going to have, now please pay attention, when you are taking the product of a bracket, make sure that the first term in the first bracket multiply all the terms in the second bracket, then you do the same for the rest, then you simplify it. Do you understand? Okay, for this, x squared times 2x, that is what? 2x cubed, 2x to the power of 3, x squared times negative 1, that is what? Negative x squared, plus 6x times 2x, that is what? Plus 12x to the power of 2, plus 6x times negative 1, that is what? Negative 6x, plus 1 times 2x, that is what? Plus 2x, plus 1 times negative 1, that is what? Negative 1. Okay, now let us simplify by collecting like sign. 2x cubed, okay, negative x squared plus 12x squared, that is what? Plus 11x squared. Okay, minus 6x plus 2x, that is what? Minus 4x, then minus 1. Okay, so the product of f of x and g of x is 2x cubed plus 11x squared minus 4x. You understand? Okay, so let's move to the fourth question now. That is f of g of x. You see, if you are part of our previous class, you will have known how to solve all this, because I take time to explain very well in that aspect. Okay, now for the fourth question, we have f of g of x. That is the fourth question, f of g of x. Don't forget, I told you that f of g of x can be written as, this can be written as f of g of x. You understand? That is, we are going to plug in the value of gx inside the function fx. That is the meaning of this statement. You understand? You are going to replace, since we know that f of x is what? X squared plus 6x plus 1. Now, f of g of x means that instead of having x here, we're going to substitute x as the value of g of x. And g of x is what? 2x minus 1. Do you understand? Okay, so let us proceed. Having known that fx is this, so anywhere I see x here, I'm going to replace it as 2x minus 1. So I'm going to have, instead of x squared, I'm going to have 2x minus 1 squared. Oh, this one is going to be a bit longer. So I want to erase this so that we can actually utilize the space that we have. Okay. So for this, I'm going to have question number 4 now. Question 4, that is f of g of x. F of g of x is equivalent to f of gx. So I'm going to have 2x minus 1 to the power of 2 plus 6 into bracket 2x minus 1, okay, then plus 1. Do you understand now? G of x is what? 2x minus 1. F of g of x means that I'm substituting g of x inside the function fx. Okay, so if you do that, you're going to have something like this. Instead of x, I replace at 2x minus 1. So if you expand this bracket, you're going to have 4x squared minus 4x plus 1 plus 12x minus 6 plus 1. Okay, so here you're going to have, now just for this like time, you're going to have 4x squared minus 4x plus 12x, that is what? Plus 8x. So I'm going to have plus 8x. Okay, now we have plus 1 minus 6. Okay, minus 6 plus 1, that is what? Minus 5, right? Minus 5 plus 1, that is what? Minus 4. So I'm going to have minus 4. Okay, so the value for f of g of x is 2x squared plus 8x minus 4. Okay, now I want you to pay attention. We are done with question 4, right? Yes. Now I want to try this question 5. You understand? I want to try this question 5. Pause the video, then when you are done with your solution, play the video and watch the solution. Maybe you got it correctly. Okay, so I'm going to provide solution to it now. Okay, for question now for question 5, we have g of f of x. Now don't forget that g of f of x can be written as g of f of x. You understand? Which means that instead of x in the function gx, instead of x in function gx, we're going to substitute fx inside gx. You understand? And don't forget that fx is what? X squared plus 6x plus 1. You understand? So for this, I'm going to have f of x, and g of f of x is 2. Instead of x, I'm going to have f of x. F of x is what? X squared plus 6x plus 1. So I'm going to have 2 multiplied by x squared plus 6x plus 1. Okay, then minus 1. Okay, so for this I'm going to have 2x squared plus 12x plus 2 minus 1. 2x squared plus 12x plus 1. Okay, so that is the final answer. That is the answer to that one. Now for the last question, which is f of the inverse of gx. Now before you can solve the last question, before you can solve that question, you have to first find the inverse of g of x. You understand? Listen to question 6. For question 6, we have f of g inverse of x. F of g inverse of x. This simply means f of g. You understand? So now what we are going to look for, we first have to determine the inverse of gx. You understand? It is that inverse that we're going to substitute inside the function of fx. Listen to the explanation again. We have f of g inverse of x. We first have to determine the inverse of function gx. So it is that inverse that we're going to replace as the value of x in the function fx. Do you understand? Okay, so in an attempt to help us to simplify that, let us first determine the inverse of the function gx. Okay, now let us determine the inverse of function gx. Now if you have been following this class, you will discover that if you want to take the inverse of a function, I gave you the simplest way to do that. So we just have to repeat the process to get the inverse of that function. Now don't forget that gx is what? 2x minus 1. G of x, okay, g of x is equals to 2x minus 1. Okay, now let y, please pay attention, let y is equals to 2x minus 1. Now I want to determine the inverse of function gx. You understand? Honestly, if I'm solving this in exam, I may not show this solution, but because I'm teaching, I just show it to you. You understand what I'm saying? So it might not be part of your solution. Okay, now we have let y is equals to 2x minus 1. Now the next step is that you have to make x the subject of the relation in this equation. So I'm going to have y plus 1 equals to 2x. So to make x the subject of the relation, I'm going to divide both by what? By 2. Hence, I'm going to have this divided by 2, this divided by 2, and this divided by 2. So so x is equals to y plus 1 all over 2. Now, having made x the subject of the relation, you have to interchange, okay? You have to interchange the variable. Now, I'm coming. You have to interchange the variable. That is, instead of x being here, you're going to replace that y. And inside the variable that you have, instead of y, you're going to replace that x. So, instead of x here, I'm going to have y. Instead of y here, I'm going to have x. So I'm going to have x plus 1 all over 2. So the inverse of the function gx is equals to, g of x is equals to 2x minus 1 is x plus 1 all over 2. Now, this is what I'm going to substitute into the function f of x. You understand? So, honestly and ordinarily, if you substitute the value of gx directly, you're not going to arrive at you're not going to get the answer correctly. Okay? So, having gotten the inverse of gx, we can now proceed to find f of inverse of gx. Okay? F of inverse of gx will now be x plus 1 all over 2 squared, you understand, plus 6x plus 1 all over 2, then plus 1. Okay, so don't forget that the inverse of gx, inverse of function gx is what? X plus 1 all over 2, you understand? So now all you have to do here now is just simplification. Okay, you just have to simplify. So with that being said, simplify as much as possible to get your answer. So just take the square of this and then you are done with the solution. So if you are given this kind of question in the exam, that is the best way to go about it. Okay, in this class we're going to learn how to find the inverse of a function. Okay, let's consider the question on the board. Okay, let's consider the question that we have on the board. We are asked to find the inverse of these functions. Okay, let's start with the first question. Now, if you are given this function in exam and you are asked to find the inverse, the first step is that, okay, we have a, that is question A, we have f of x is equals to 3x minus 2. Now, let y be equals to 3x minus 2. Please pay attention, that's the first step. Let y be equals to 3x minus 2. Now, having done this, the next step is that you have to make x the subject of the relation, okay? So, for this, I'm going to have y plus 2 is equals to 3x, okay? If I want to make x the subject of the relation, I'm going to divide both sides by 3, which is the coefficient of x. So I'm going to have this divided by 3 and this divided by 3. So the value of x will be x is equivalent to y plus 2 all over 3. Now, when you get to this point, having made x the subject of the relation, you have to replace x as y and y as fx. You understand? This is what I mean. You know that here I said let y be equals to 3x minus y and 3x minus 2. Y here signifies fx. You understand? So now in this expression that I have here, I'm going to replace y that I have here as x. So the function will now become like this. The function will become like this. X is equals to, okay, the function will become like this. Y is equals to x plus 2 all over 3. Now, do you know what I did? I replaced x as y and y as x. You understand? See, x is here. That means I'm going to have y here, and instead of y here, I'm going to have x. That's what I did, okay? So, in that case, the inverse of the function the inverse of this function will be equals to x plus 2 all over 3. Do you understand? Inverse of f of x. Oh, sorry. This should be minus 1. Inverse of f of x is x plus 2 all over 3. Do you understand now? Okay, let's attempt the second question. For the second question, we have B. Question B. G of x is equals to square root of x minus 3. These are the likely questions that might come out in your exam, so make sure you pay attention. Now, the first step is that let's represent g of x as y. So I'm going to have let y equals to square root of x minus 3. Now, the next step is that you have to make x the subject of the relation. And to make x the subject of the relation, you have to eliminate this square root. So, if you want to eliminate this square root, what are you going to do? Take the square of both sides. So, I'm going to have y squared is equals to x minus 3. Okay? Hence, I'm going to have y squared plus 3 is equals to x. So, x is equals to y squared plus 3. Now, having gotten to this point, the next step is that we approach it like we did the other time. You replace y as x, you understand? So the function will become like this. You replace y as x and x as y. That is, you interchange. That is what we call inverse, you understand? So for this, I'm going to have y will be equals to x squared plus 3, you understand? Now, because I said y is equals to I said let y be equals to this. So the inverse of the function g of x, the inverse of this function will be x squared plus 3. Do you understand? Okay, let's have the third example. We have h of x is equals to x plus 4. Okay, yes, h of x is equals to x plus 4 all over 2x minus 5. Okay, how do we find the inverse of h of x? For question C now, we have h of x is equals to x plus 4 all over 2x minus 5. This one, the first step also is that just let y be equals to the function, then make x the subject of the relation. Okay, let y be equals to x plus 4 all over 2x minus 5. You understand? So now here I'm going to make x the subject of the relation. Do you understand? So when I'm done, I'm going to interchange the value of x as y and y as x. Then I'm going to put y as h of x. So having set y equals to the function that we have, you have to make x the subject of the relation. You understand? Then when you are done, you have to interchange the value of x as y and y as x. You understand? So let us proceed. For this, we are going to have now make x the subject of the relation. I'm going to have y multiplied by 2x minus 5 is equivalent to x plus 4. Okay. Now 2xy minus 5y is equals to x plus 4. Okay. Take x to the other side. I'm going to have 2xy minus x is equals to 4 plus 5. 4 plus 5y. Now, you have to factorize, you understand, because the goal is to make x the subject of the relation. So, I'm going to factorize because x is common to both 2xy and negative 1. So, I'm going to have x is equal, put the bracket, 2y minus 1 is equals to 4 plus 5y. Okay, divide both by 2y minus 1 and this over 2y minus 1. What are you going to have? X will be equivalent to 4 plus 5y all over 2y minus 1. Now, so having gotten to this point, you have to interchange x as y and y as x. So I'm going to have y is equals to 4 plus 5y all over 2y minus 1. Now, that means I'm going to write y as the inverse of h of x because the inverse of this function is indeed x plus 4 plus 5y all over 2y minus, this should be x. 4 plus 5x all over 2x minus 1. You understand? The inverse of this function is this. So now that means that if this function is equals to hx, the inverse of this function will be the inverse of hx. You understand? So I'm going to have the inverse of h of x is equals to 4 plus 5x all over 2x minus 1. Do you understand? Okay, so whenever you are asked to find the inverse of a function, the first step is that set the function equals to a letter, maybe y. Then when you are done making the variable that is the input, when you are done making it the subject of the formula, you have to interchange that variable. That the answer that you got will be the inverse of the initial function. Do you understand? In this class, we're going to talk about even and odd function. When do we say a function is even or odd? A function is said to be even if it satisfies this condition. That is, any function that you are going to call an even function must satisfy this condition. What is the condition? F of x must be equivalent to f of negative x. If a function satisfies this condition, that means such function is an even function. Okay? Please note it, even function. If a function satisfies this condition, such function is an even function. Now, for the odd function, when do we say a function is odd? Well, a function is odd if it satisfies the following condition. If f of x is equals to negative f of negative x. If the function satisfies this condition, the function is said to be odd. You understand? The function is said to be an odd function. Okay, now, having learned what is meant by even and odd function, let's look at some example. Determine whether the following functions are even or odd function. Okay, we are asked to determine whether the following functions are even. We have, for A, we have 2x squared minus x to the power of 4. And for B, we have x to the power of 3 minus 2x. And for C, we have x to the power of 3 minus 6x squared. Okay, so given these questions, how do we test whether these functions are even or odd? Don't forget the condition. If fx is equals to f of negative x, that function is said to be even. Okay, now let's go. Let's start with the first question. We have question A. Let fx is equal to 2x squared minus x to the power of 4. Okay, now let fx, please, I start with the first question now, which is question A, 2x squared minus x to the power of 4. I want to test whether this function is an even function or not. So I said let fx is equivalent to this. Now f of negative x will be equals to 2 negative x squared minus negative x to the power of 4. Okay, now listen to me. I'm very sure you are part of our previous class. If you are part of the class, I'm very sure you know what I did here. If fx is equals to 2x squared minus x to the power of 4, f of negative x will be, I just have to replace the value of x as negative x. So now I'm going to simplify this to see if I'm going to have 2x squared minus x to the power of 4. Eventually, if I got 2x squared minus x to the power of 4, when I simplify this, that means that this function is an even function because it satisfies the condition. Okay, so let us proceed. Let us simplify. Here I'm going to have minus x to the power of 2. Minus x to the power of 2 is what? Minus x times minus x. So I'm going to have x squared. So I'm going to have 2x squared. Now we have minus x to the power of 4. Minus x to the power of 4 is minus x times minus x times minus x times minus x. You understand? Okay, minus x times minus x, that is minus plus x squared. plus x squared times minus x, that is negative x to the power of 3. Negative x to the power of 3 times negative x, that is positive x to the power of 4, which is the same thing as x to the power of 4. So this is x to the power of 4. Now here I'm going to have minus x to the power of 4. So this will give me 2x to the power of 2 minus x to the power of 4. Hence, because fx, which is 2x squared minus x to the power of 4, is equivalent to f of minus x. That means that this function here is an even function. Do you understand? Okay? Because fx, which is this function itself, is equivalent to f of minus x, which is what? 2x squared minus x to the power of 4. This implies that question A is an even function. Okay? So this is an even function. Okay? Now let us proceed to the question, to the second question. Question here. For the second question, we have let f of x is equals to x to the power of 3. F of x is equivalent to x to the power of 3 minus 2x. Okay, now we want to test for f of minus x. Now listen to me. Listen to me carefully. What I'm doing right now is that I'm testing all the functions, whether they are even function. You understand? Okay, I'm testing all the functions, whether they are even function. Do you understand? So I've already tested for question A. I discovered that it's an even function. Now I'm on question B now. For this, I'm going to have f of minus x, because a function that will be an even function must satisfy both conditions. The f of x, which is the function itself, must be the same as f of minus x. So let us go. I'm going to replace minus x as x in this place. So I'm going to have minus x to the power of 3 minus 2 into bracket minus x. Okay? So if you simplify this, you are going to have minus x to the power of 3 will give us minus x to the power of 3. Because minus x to the power of 3 simply implies that minus x times minus x times minus x. If you take the product of minus x in 3 places, you are going to have minus x cubed. You understand? So minus 2 times minus x, that is what? Plus 2x. You can see now. So you can see that this fx, which is x cubed minus 2x, is not equivalent to f of minus x. So this function is not an even function. Okay? This function that you see here, the second function, is not an even function. Okay? Now let us test for the maybe it is an odd function. It's still the same question. Okay, we are still on question B. We test for an even function. We discover that the function is not an even function. Now we want to check maybe this function is an odd function, and for a function to be an odd function, that means that f of x must be equivalent to negative f of negative x. You understand? So here I'm going to have, please pay attention. So don't forget that f of x is this, f of negative x is this. So we want to test maybe this function is an odd function. We have already proven that it is not an even function. So for an odd function, all you have to do is that just multiply f of negative x by a negative sign. You understand? And don't forget that f of negative x is minus x to the power of 3 plus 2x. So if I multiply this f of negative x by a negative sign, if I multiply the function by a negative sign, that if I got x cubed minus 2x, that means the function is an odd function. Do you understand? Okay, let us proceed. To check maybe the function is an odd function, I have to multiply f of negative x by a negative sign. You understand? Like what I have here. F of x is this, minus f of negative x is this, and I've already gotten f of negative x, which is what? Minus x cubed plus 2x plus 2x. So multiplying this, multiplying s of x minus s cubed plus 2x. Yes, if you multiply, you're going to have x to the power of 3 minus 2x. Now you can see that By when I multiply this function by negative sign, I have x to the power of 3 minus 2x, which is equivalent to the function that we have, or which is equivalent to the question that we are given. That means that this function is an odd function. Do you understand? Okay, how do I know that it's an odd function? I tested, maybe it is an even function. I discovered that it is not, because it doesn't give me exactly the function. You understand? When I test for f of negative x, you understand? So now to check maybe it is an odd function, I multiply f of negative x by negative sign, just like what we have, the condition that must be met for a function to be an odd function. So having multiplied by negative sign, I discovered that I got s cubed minus 2x. You can see that it's the same. Hence, the second function is an odd function. The second function is an odd function, okay? Now, we want to test whether the third s cubed minus 6x squared is an odd function or is an even function. Don't forget, this is the two conditions that we are examining. If you examine these two conditions on this function and it met any of them, then the function is said to be either odd or even. You understand? So let us proceed. For this, I'm going to have, let f of x, that's question C now, let f of x be equals to s to the power of 3 minus 6x to the power of 2. Okay, now we first want to test whether it is an whether it is an even function. So I'm going to take f of negative x. F of negative x will be equals to negative x to the power of 3 minus 6 into negative x to the power of 2. Okay, now simplify. I'm going to have negative x to the power of 3. That is what? Negative x to the power of 3. Now, negative x squared will be what? X squared, because negative x squared is negative x times negative x, which is positive x squared. So I'm going to have minus 6x squared. Okay, now having tested whether the function is an even function or not, I discovered that it is not an even function. Why? Because what I have here is not the same thing as s cubed minus 6x squared. Now, it doesn't satisfy the condition to be an even function. Now, let us test maybe it's an odd function. How do we test maybe it's an odd function? All you have to do is that, because an odd function, for an odd function, fx must be equals to negative f of negative x. You understand? So for this, you are going to have, just multiply this function by a negative sign. So I'm going to have minus f minus x will be equals to minus x to the power of 3 minus 6x squared. Okay, now let us go. For this, I'm going to have minus f of minus negative x will be equals to minus multiplied by x cubed. That is what? Negative x cubed. Negative multiplied by negative 6x squared. I'm going to have positive 6x squared. So that will be what? 6x squared minus s cubed. So let us check. We have 6x squared minus s cubed. You can see that this function, the third function, is neither even or odd function. It's not an even function. It is also not an odd function. So we cannot call it any of them. You understand? So for that kind of function, you can just put yes. Having understand what is meant by even and odd function, it is also possible to check whether a function can be written as the sum of an even and an odd function. Okay, please kindly pay attention. It is also possible to know, you can check whether a function can be written as the sum of an even and an odd function. A function, please pay attention, there is also a condition for that. For a function to be written as the sum of an even and an odd function, that function must must satisfy this condition. Okay, f of x must be equivalent to 1 over 2. Please pay attention. 1 over 2 f of x plus f of minus x. You understand? 1 over 2 f of x plus f of minus x, then plus 1 over 2 f of x minus f of minus x. Okay, a function, please pay attention, a function that can be written as the sum of an even and an odd function, it must satisfy this the following condition. Now pay attention. If you look at this formula, listen, if you look at this formula, you will discover that f of negative x is what? That is for an even function, right? Now f of minus f minus negative minus f of minus f of negative x, that is what? For an odd function. So what we are actually trying is that, can a function be written as the sum of an even and an odd function? Okay, well, let us look at some example. Any function that satisfies this following condition can be written as the sum of an even or odd function. Okay, so let's look at work example. Show that the following function can be written as the sum of an even and an odd function. Okay, show that the following function can be written as the sum of an even. Okay, we have x to the power of 3 minus 6x to the power of 2, and we have for question B, we have into x sine x. Okay, we are asked to show whether the function on the board can be written as the sum of an even and an odd function. Now, don't forget, I told you any function that can be written as the sum of an even or an odd function, it must satisfy this condition. Okay, so let's start with the first question. We have, let fx, I'm starting with this question now. Let f of x be equivalent to x to the power of 3 minus 6x to the power of 2. Okay? Now, fx, which is this? So I'm going to have x to the power of 3 minus 6x squared must be equals to, for it to be, for this function to be able to be written as the sum of an even and odd function, it must satisfy this condition. So I said let fx equals to the function itself. So because it must satisfy the following condition, I just bring this fx, which is this, equals to 1 over 2, okay, 1 over 2 f of x, okay, f of x is what? X squared minus 6x squared, s cubed minus 6x squared, okay, plus f of negative x. Now, from our previous class, or even if you are following along, we will discover that if you want to get the f of negative x of this, we are going to have f of negative x will be minus x to the power of 3, is that not it? Then minus 6x squared. That is the f of negative x. If you missed the previous class, you can check the channel to watch those classes. Okay, we have done something like this, how to determine whether a function is even or odd. If you missed those classes, you can check. Okay, now, so f of negative x will be negative x squared minus 6x squared. What I did was that I just substituted the value of x as negative x, so there's nothing wrong, there's nothing much about that. Okay, now f of negative x will now be minus, okay, minus x to the power of 3 minus 6x squared. Okay, close the bracket. Now, plus 1 over 2. Now we are dealing with the second side now. Listen, f of x is this. F of negative x is this. You understand? So I just substitute the value of f of negative x as this. You understand? So now we are dealing with this second side. We are still going to have f of x. F of x is what? S cubed plus minus 6x squared. S cubed minus 6x squared. Okay, s cubed minus 6x squared. Now plus, now we still need the negative f of negative x. We still need to determine negative f of negative x. So let us quickly do that. Negative f of negative x will be x to the power of 3 plus 6x squared. You understand? Negative x to the power negative f to negative f of x. I mean negative f of negative f of x. We negative of negative f of negative x will be x to the power of 3 plus 6x squared. You understand? So now I'm going to replace negative f to the power negative f of negative x as x to the power of 3 plus 6x squared. So I'm going to have plus x to the power of 3 plus 6x squared. You are wondering how I got this. All I did was that I just multiplied this function by a negative sign. Negative times negative x cubed, I'm going to have s cubed. Negative times negative 6x squared, I'm going to have plus 6x squared. So I've not done anything. Okay? So just pay attention, you're going to understand. Now for this, just put the bracket and then put the big bracket. Now the goal is to test whether this side is equal to this side. If this side is equal to this side, that means this function, the first function s cubed minus 6x squared, can be written as the sum of an even or an odd function. You understand? Because this one is even while this one is odd. Okay, let's proceed. For this, I'm going to have x to the power of 3 minus 6x to the power of 2. Oh yeah, let's simplify. So you're going to have here x to the power of 3 minus 6x to the power of 2 minus x to the power of 3 minus 6x to the power of 2. Okay, this all over 2. Okay, this additional sign, bring it here, plus. Now let us simplify the other side as well. We're going to have x to the power of 3, are you there, minus 6x to the power of 2 plus x to the power of 3 plus 6x to the power of 2. You understand? So now, okay, all these divided by 2 as well. Now we can simplify the numerator. I mean the numerator of the both fraction as the right hand side. So I'm going to have x to the power of 3 minus 6x to the power of 2 is equivalent to, now we have, please pay attention, x plus s cubed minus s cubed. This can cancel this. So we are left with what? Minus 6x squared minus 6x squared. Minus 6x squared minus 6x squared, that will be what? Minus 12x squared. So I'm going to have minus 12x to the power of 2, this all over 2 plus. Now for the other side of the fraction, we have s cubed minus 6x squared plus s cubed plus 6x squared. Now from this point, this negative 6s cubed can eliminate this. So we are left with what? S cubed plus s cubed. S cubed plus s cubed is 2x cubed. So I'm going to have plus 2s cubed all over 2 plus 2s cubed all over 2. Do you understand? If you get to this point, then you are done. You are almost done with the solution. Okay. Now for this, let us divide. I'm going to have x to the power of 3 minus 6x to the power of 2 is equals to minus 6x squared, because if you divide negative 12 by 2, you're going to have negative 6. negative 6 times x cubed, that is negative s cubed. You understand? So for this, I'm going to have plus s to the power of 3. Now, let us check whether the side is equivalent to this side. Don't forget that we can rewrite this. Minus 6x to the power of 2 is equals to, now, we can rewrite this function, this side as x to the power of 3 minus 6x squared. You can see that this side is equivalent to this side, which means that fx, which is s cubed minus 6x squared, is equivalent to, when we substitute all the value that we have here and we simplify it, we got the right hand side of this equation as s cubed minus 6x squared. That means that this first function, which is x cubed minus 6x squared, satisfies this condition. Do you understand? Because for a function to be the sum, for we to check whether a function must be, can be a sum of an even and odd function, that function must meet this condition. And because of function a, which is s cubed minus 6x squared, met the condition, it can be written as the sum of an odd and even function. Do you understand? Okay. Now, I'm very sure you can do question B. You can go ahead and test. You understand? You can go ahead and test. Though I'm still going to provide the solution. Okay, just pay attention. Okay, let's proceed to the second question. We have now f of x will be into x sine x into x sine x. Now, because you know from the previous example, we need f of negative x and negative f of negative x. You understand? So let us quickly determine it. F of negative x will be in negative 2x sine negative 2x, sine negative x. Okay, and then negative f of negative x will be minus negative in, please pay attention, negative in negative 2x sine negative x. Put the big bracket. Okay, if you didn't understand, listen to the explanation again. To get f of negative x, all I did was that I just replaced the value of x in this function by negative x. You understand? And because I have into x here, when x becomes negative, I'm going to have negative 2x. You understand? So I have negative 2x here, and because I have sine x, that will be what? Sine negative x. Now, to get negative f of negative x, you can see that I just put all these things, all this function that you have here, I just put inside the bracket. Okay, so I multiply by negative. That's all. If you didn't understand, listen to the explanation again. Okay, now having gotten f of negative x and negative f of negative x, you can now test maybe this function will be equal to this. So f of x must be equals to 1 over 2 fx. Fx is what? In 2x sine x. Open the bracket. In 2x sine x plus f of negative x. That is what? In negative 2x sine negative x. Close the bracket. Plus 1 over 2. Open the big bracket. F of x, which is what? In 2x sine x. In 2x sine x, okay, minus negative f of negative x. So I'm going to have negative in negative 2x sine negative x. Close the bracket. You can see that we are almost done. Okay, so we want to test maybe f of x is equals to this. If it is equal, that means the function can be written as the sum of an even and odd function. You understand? But if it is not equal, if fx is not, if this is not equals to in 2x sine x, that means it cannot be written like that. Okay, so let us proceed. For this, I'm going to have Now into, okay, let's proceed. In 2x sine x plus in negative 2x sine negative x, okay, this all over 2, don't forget this 2, plus in 2x sine x negative in negative 2x sine negative x, okay, all over 2. Okay, the next step now is that you have to take the LCM. Okay, so the LCM here will be what? 2. The LCM will be 2. Okay, the LCM will be 2, so just put 2 at the denominator. Now for this I'm going to have in 2x sine x plus in negative 2x sine negative x plus in 2x sine x minus in negative 2x sine negative x. Okay, do you know what I did? I take the LCM. The LCM of this fraction and this fraction is 2. So I take the LCM. 2 divided by 2, 1. 1 times all this, that's this. 2 divided by 2, 1. 1 times all of this, that will be this. Okay, and the reason why I put this in brackets is because this negative sign is affecting both in negative 2x and sine minus x, you understand? So it's very important that you pay attention to that. Now, having gotten to this point, you have to simplify the numerator. We have into plus into x sine minus x here, and we have minus into, we have plus in negative 2x sine minus x here, and we have negative in minus 2x sine negative x. So this can eliminate this, and so we are left with what? We are left with into x sine x plus into x sine x. That will be what? 2 into x sine x. If you didn't understand, kindly listen to the explanation. Okay, all we are doing is that we want to check, maybe when we simplify this function, we are going to have fx. Don't forget that we have already said that let fx be equal to what? Into x sine x. Okay, so we want to check, maybe if we simplify this, we are going to have into x sine x. If we have into x sine x, that means that the function can be written as the sum of an even and an odd function. Okay, so now because we sum this together, we're going to have 2 into x sine x. I'm going to have this over 2. Now you can divide both sides, you can divide the numerator by these 2. So we're going to have in 2x sine x. You can see that this function is equal to this function. When we simplify this, we get in 2x sine x. That means that both of the function can be written as the sum of an even and an odd function. Do you understand? If you do understand, let me know in the comment section. Okay, the function can be written as the sum of an even and an odd function. So, and the reason is because it met the criteria, like it met the condition. Don't forget this. For a function to be for we to be able to write a function as the sum of an even or an odd function, that function must be equal to the sum of the function and the even of that function divided by 2 plus sum of the function and the odd of that function divided by 2. You understand? Okay, so if you missed the previous class, kindly check the playlist on this channel and watch those classes, okay, to understand more on even and odd function. Okay, so that's all.